Hello, in this lecture we'll answer on two questions. In the first question we'll find out the area of square ABCD. In the second question we'll find out the size of this angle theta, in triangle DOE. We start with the first question. In the drawing we have square ABCD. We know that line segment AP equals to 5 units, line segment VP equals to 3 units, line segment CP equals to 6 units, and our mission is to find out the area of this square ABCD. So first of all we'll do a construction. We'll extend side DC of the square by a straight line. And from point P we will draw perpendicular on the extended side DC. So this angle equals to 90 degrees according to our construction. We will define the touching point of the perpendicular from point P in the extended DC as N. In the next step we will do another construction. From point B we will draw perpendicular on PN. Again from point B we will draw perpendicular on PN. So this angle equals to 90 degrees, and this angle is also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and PN as M. In the next step we define side BM as A. That is to say, side BM equals to A units according to our definition, and we define side PM as B. That is to say, side PM equals to B units according to our definition. In the next step we will implement the Pythagoras theorem on the right green triangle PMB. So according to the Pythagoras theorem, on the right triangle PMB, here by PT is the relation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse of the green right triangle PMB is PB. And therefore the square of the hypotenuse is PB squared, and it must be equal to the sum of the square of the perpendiculars. That is to say, it must be equal to PM square plus BM square. I'll repeat again, the right main triangle PMB, according to the Pythagoras theorem, PB square equals to PM square plus BM square. PB, the hypotenuse PB is equal to 3 units according to what is given as the question. Therefore, the square of the hypotenuse is PB square, that is 3 square, that is equal to 9. And it is equal to PM square. PM equals to B, therefore PM square is B square plus BM square. BM equals to A, therefore BM square will be equal to A square. So actually, according to the Pythagoras theorem, we got in equation number 1 that A square plus B square equals to 9. We know that all the angles inside a square are equal to 90 degrees, so all the angles inside square ABCD must be equal to 90 degrees. Those angles are all right angles in this square ABCD. DC is one side of square ABCD, therefore it is absolutely a straight line. Then we extended the straight line DC by a straight line, and the result is DN. When you extend a straight line by a straight line, the result must be a straight line, therefore DN must be a straight line. I write it down, DN is a straight line. This line, segment by segment DN, is a straight line. And if we focus on the upper side of the straight line DN at point C, here the sum of the angles must be equal to 180 degrees. So which angles we have at the upper side of DC, of the upper side of DN at point C? We have this angle that is equal to 90 degrees plus angle BCN. In total, the sum of those two angles must be equal to 180 degrees. According to rule number 3, that the sum of the angles on one side of a straight line is equal to 180 degrees. Here, 90 degrees plus the size of angle BCN, in total, they must be equal to 180 degrees. According to rule number 3, here we subtract 90 degrees from this equation, and we get that the missing angle BCN, is equal to 180 degrees minus 90 degrees, it is 90 degrees. So we found out that the missing angle is equal to 90 degrees. This angle equals to 90 degrees. So inside quadrangle BMCN, we have 1, 2, 3 right angles. And the sum of 3 right angles is 270 degrees. Therefore, this fourth angle must be also equal to 90 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So in order to complete the sum of the angles in this quadrilateral to 360 degrees, this angle must be equal to 90 degrees, because 270 degrees plus 90 degrees is 360 degrees. So inside quadrilateral BMCN, we have 4 right angles. We'll return to this quadrilateral later. So we focus on the lower side of line segment AM, and the lower side of line segment AM is point B. This angle equals to 90 degrees, and this angle is also equals to 90 degrees. 90 degrees plus 90 degrees is 180 degrees. That is to say, angle ABM, this angle, it is equal to 180 degrees. So I write it down, angle ABM equals to 180 degrees, and any angle that is equal to 180 degrees must be a straight line. Therefore, angle ABM is a straight line. So, if angle ABM is a straight line, then line segment ABM is a straight line, and if line segment ABM is a straight line, it means that AM is also a straight line. So I write it down, AM is a straight line. AM is a straight line. So if AM is a straight line, it means that triangle APM, this triangle, or actually shape APM, this shape must be a right triangle. Okay, shape APM is a right triangle. Therefore, we implement the Pythagoras theorem on the right green triangle, triangle APM. According to the Pythagoras theorem, on the right green triangle, triangle APM, by PT is a relation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right green triangle, triangle APM is AP. Therefore, the square of the hypotenuse is AP squared. And it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to PM squared plus AM squared. I repeat again, in the right green triangle, triangle APM, according to the Pythagoras theorem, AP squared equals to PM squared plus AM squared. Here we will define the side length of square ABCD as x. Therefore, all of its sides will be equal to x units in their lengths. So, according to equation number 2, we found out that AP square. AP, the product AP equals to 5, therefore AP square is 5 squared, that is 25. And it is equal to PM square. PM equals to B, therefore PM square is B square plus AM square. What is the length of AM? AM equals to X plus A, therefore AM square will be equal to X plus A square. So according to equation number 2, we found out that 25 equals to B square plus X plus A square. Here we'll open the brackets on this side of equation number 2 and we get that according to equation number 2, 25 equals to B square plus X plus A square equals to X square plus A square plus 2 times AX. In this equation number 2, we have B square plus A square, and we have already found out that B square plus A square according to this equation number 1 equals to 9, therefore we substitute B square plus A square in this equation number 2 by 9, and we get that 25 equals to 9 plus X square plus 2AX. Here we subtract 9 from this equation number 2, and we get that according to equation number 2, (25 minus 9 is 16), that is equal to X square plus 2AX. Here we subtract X square from this equation number 2, and we get that according to equation number 2, 16 minus X square equals to 2AX. Here we divide this equation number 2 by 2X, and we get that according to equation number 2, A equals to 16 minus X square over 2X. So we found the value of A in terms of X. Okay. Now we will return to quadrilateral BMCN. We already found out that inside quadrilateral BMCN we have 4 right angles, therefore quadrilateral BMCN is a rectangle. I write it down. Quadrilateral BMCN is a rectangle because it has 4 right angles. And we know that the opposite sides of a rectangle are equal to each other. That is to say, BM equals to CN. BM equals to CN. But according to our definition, BM equals to A units. So we can write here BM equals to A. And from this equation, A equals to BM equals to CN. we derive that Cn is also equals to A. Cn is equal to A. We can write down that Cn equals to A. Likewise, according to the same rule, with the opposite sides of a rectangle are equal to each other, we'll get that BC equals to MN. BC equals to MN. But according to our definition, BC equals to X, so we can write here that BC equals to X. And for this equation, X equals to BC equals to MN, we will derive that MN is also equals to X. MN equals to X. MN equals to X. So in the next step, we'll implement the Pythagoras theorem on the right green triangle, triangle PCN. The right green triangle, triangle PCN by PT, again is a relation for Pythagoras theorem. The square of the hypotenuse equals to, by PT is a relation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right green triangle, triangle PCN is PC. Therefore, the square of the hypotenuse is PC square. And it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to Pn square plus Cn square. I'll it again in the right green triangle, triangle PCN. PC square equals to Pn square plus Cn square. The hypotenuse PC equals to 6 units according to what is given as the equation. Therefore, PC square will be equal to 6 squared, that is 36. And it is equal to Pn square. What is the length of Pn? Pn equals to B plus X. B plus X. Therefore, Pn square is B plus X square plus Cn square. Cn equals to A, therefore Cn square is A square. So in conclusion, we found out that according to equation number 3, 36 equals to B plus X square plus A square. Here we'll open the brackets on this side of equation number 3 and we'll get that according to equation number 3, (36) equals to B plus X square is B square plus X square plus 2bx plus A square. So again, here we have in equation number 3 B square plus A square, and we already found out that B square plus A square according to equation number 1 is 9, so we substitute B square plus A square in this equation number 3 by 9. And we get that according to equation number 3, 36 equals to 9 plus X square plus 2bx. Here we subtract 9 from this equation number 3, and we get that according to equation number 3, (36) minus 9 is 27. That is equal to X square plus 2bx here we subtract x squared from this equation number 3, and we get that according to equation number 3, 27 minus x squared equals to 2bx. Here we divide this equation number 3 by 2x, and we get that according to equation number 3, b equals to 27 minus x squared over 2x. So we got the values of a and b in terms of x. And according to equation number 1, we have already found out that a squared plus b squared equals to 9. We have already found out that a equals to 16 minus x squared over 2x. So if we square this expression, we get a squared, of course, plus b squared. We already found out that b equals to 27 minus x squared over 2x. So if we square this expression, we get the value of b squared, that is equal to 9. According to this equation number 1. So here we'll open the brackets of those two expressions, and we get that 16 minus x squared is equal to 16 squared, that is 256, minus 2 times 16 is minus 32 times x squared, plus x squared is x to the power of 4. And because of the fact that those two expressions have the same denominator, we can add the numerator of this expression to the numerator of this expression, and we do it now, and we get that 27 minus x squared is 27 squared, that is 729, plus x squared is x to the power of 4, minus 2 times 27 is minus 54 times x squared, all divided by 2x squared, that is 4x squared, and it is equal to 9 according to this equation number 1. So here we have 256 plus 729 is 985, minus 32x squared minus 54x squared is minus 86x squared, and x to the power of 4 plus x to the power of 4 is equal to 2 times x to the power of 4, all divided by 4x squared, is equal to 9. So here we will multiply this equation number 1 by 4x squared, and we get that according to equation number 1, 2 times x to the power of 4 minus 86x squared plus 985 equals to 4x squared times 9 is 36x squared. So here we subtract 36x squared from this equation number 1, and we get that according to equation number 1, 2 times x to the power of 4 minus 86x squared minus 36x squared is minus 122x squared plus 985 is equal to 0. So here we define z as x squared, that is to say z is equal to x squared according to our definition. Z is equal to x squared, so if z equals to x squared, it means that z squared will be equal to x to the power of 4. Therefore 2 times x to the power of 4 will be equal to 2z squared minus 122. Z equals to x minus 122 x squared. X squared equals to z, so we substitute x squared by z, and we get here that minus 122 x squared equals to minus 122 z plus 985 equals to 0. So we have here a quadratic equation, 2z squared minus 122z plus 985 equals to 0 is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, the coefficient a equals to 2, the coefficient b equals to minus 122, and finally the coefficient c equals to 985, and the variable that we are looking for, x equals to z. So we put the data inside the formula for x, and we find out the value of the values of z because x equals to z. And we write down again the coefficients of our specific quadratic equation. A equals to 2, b equals to minus 122, and the coefficient c equals to 985. The variable that we are looking for, x equals to z. So we put the data inside the formula for x, and we find out the value of the values of z. So z equals to minus b. B is minus 122, so minus b is minus 122, that is plus 122, plus minus square root of b squared. B is minus 122, therefore b squared is minus 122 squared, that is 14,884, minus 4 times a is 2, so minus 4 times 2 is minus 8, times 9 times c, that is 985, minus 8 times 985 is minus 7,880 all divided by 2a. Here a equals to 2, so 2a is 2 times 2, that is 4. So here we found out in conclusion that z is equal to 122 plus minus the square root of 14,884 minus 7,880 is 7,004. So inside the root we left only with 7,004 over 4. So z equals to 122 plus minus the square root of 7,004 is 83.6899 divided by 4. So here we will have two solutions that are possible for z. The first solution for z is that z equals to 122 plus 83.6899 over 4. So here z equals to 122 plus 83.6899 is 205.6899, and if we divide this number by 4 we'll get that z equals to 51.4224. So I found out that z equals to 51.4224. But what is z? Z, according to our definition, is equal to x squared, and we just right now found out that z equals also to 51.4224. So here we take out of this equation in order to find out the value of x. So if we take out of this number the square root of 51.4221 is equal to 7.17 units. So we found out that x equals to 7.17 units. Here we found out that AB that is equal to x, it is equal to 7.17 units, and it is actually impossible that x equals to 7.17 units. Why? Because if we focus on the right triangle APM, in the right triangle APM, the hypotenuse AP equals to 5 units, and we know that the hypotenuse is the biggest side in any right triangle. So the hypotenuse AP that is equal to 5 units is biggest than side AM in triangle APM. So AP is bigger than AM. If AP is bigger than AM, let alone that AP will be bigger than AB that is part of AM. So I found out that the hypotenuse AP that is equal to 5 units is bigger than AB that is equal to x. So I write it down. In the right triangle APM, the right green triangle APM, the hypotenuse AP that is equal to 5 units is bigger than AB that is equal to x. So we have the inequality that 5 equals to AP and it is bigger than AB that is equal to x. So from this inequality we will derive that x is less than 5 units. So we found out that x must be less than 5 units. But we just right now found out that x that is equal to 7.17 units that is bigger than 5 units. So we have here a contradiction. According to what we found out, x must be less than 5 units, we found out that x is greater than 5 units. So due to the contradiction, we cancel the possibility that z equals to 51.4224 units, and we focus only on the second possibility for the solution of the quadratic equation for z. According to the second solution for z, z is equal to 122 minus 83.6899 divided by 4. That is to say, z is equal to 122 minus 83.6899 is 38.3101. 38.3101 over 4 is equal to 9.5775. So we found out that z, that according to our definition is equal to x squared, is equal to 9.5775. So here we take out of this equation, and we get that the square root of 9.5775, here it is equal to x, that is equal to 3.09 units. So I found out that x equals to 3.009 units. So here, if we focus on the right triangle, triangle APM, the hypotenuse AP is equal to 5 units, while AB is equal to 3.09 units, that is less than the hypotenuse, so we don't have any contradictions here. Therefore, we derive that, we conclude that our answer is correct. And what is actually the area of square ABCD? The area of square ABCD, it is equal to x squared. Write it down, the area of square ABCD is equal to x squared. But x squared equals to z, and we just right now found out that z equals to 9.5775. That is to say, the area of square ABCD equals to 9.5775 square units. Repeat again, the answer to the question is that the area of this square ABCD equals to 9.5775 square units. We finished with the first question. In the next step, I will present to you the second question. In the drawing, we have a right triangle ABC. This angle ABC equals to 90 degrees. Inside the right triangle ABC, we have a circle, and inside the circle we have triangle DOE, and we are looking for this angle theta. it has been given us to the question that AD equals to EC and DE is twice as long as AD and DE is twice as long also as EC, and our mission is to find out the size of this angle theta. So first of all we define side DE as 2A. Here side DE equals to 2A according to our definition. And according to what has been given us the question, we know that AD equals to CE, that is equal to DE over 2, but according to our definition DE equals to 2A, so we substitute DE by 2A. 2A over 2 is A. So from this long equation, we derive that AD equals to CE, that is equal to A. So we can write down here that AD equals to A and EC is also equals to A. In the next step, I will present to you rule number 4 and we will implement rule number 4 in our drawing. According to rule number 4, the perpendicular from the center of a circle to a chord bisect the chord. The center of the circle is at point O. From point O we have perpendicular OM, and according to this rule number 4, the perpendicular OM bisect chord CD. That is to say, CM equals to MD. And we also know that CM equals to CD over 2 and MD is also equals to CD over 2. Why? Because chord CD has been bisected into two halves. Each half equals to CD over 2. So we can implement rule number 4 in our drawing. From the center of the circle, that is to say from point O, we draw perpendicular to chord DE. So this angle equals to 90 degrees and this angle will be also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and chord DE as T. And here, actually, according to rule number 4, we will get that dt equals to TE, dt equals to TE, and each part is equal to DE over 2 because chord DE has been bisected into two halves by perpendicular OT. So DE is dt equals to DE over 2 and TE is also equals to DE over 2. Okay, again is equal to DE over 2, but according to our definition DE is equal to 2A, so we substitute DE by 2A, 2A over 2 is A. So from this long equation, D equals to T equals to D over 2 equals to 2A over A equals to A, we will derive that dt is equal to TE, that is equal to A. That is to say dt is equal to A and TE is also equals to A. in the next step, we'll define the point of tendency of tangent AB with this circle as point M. We will define the point of tendency of tangent BC with this circle as point N. We will join points O and M together by a straight line. Point O is the center of the circle. Point M is the point of the circle itself. Therefore, OM is the radius of the circle that we define as R. So OM equals to R. And we have the radius OM that is drawn to the point of tendency. Therefore, according to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. This angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, we join points O and N together by a straight line. Point O is the center of the circle, point N is the point of the circle itself, therefore ON is the radius of the circle that is equal to R. And again, we have the radius ON that is drawn to the point of tendency, therefore according to rule number 1, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. So inside quadrilateral MOBN, we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees. So we have 4 right angles inside quadrilateral MOBN, therefore quadrilateral MOBN is a rectangle. I write it down. Quadrilateral MOBN is a rectangle because it has 4 right angles. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, MO equals to BN. MO equals to BN. But MO equals to R, according to what we already found out. MO equals to R. And from this equation, R equals to MO equals to BN, we will derive that BN is also equal to R. BN is equal to R. Yeah. Bn is equal to R. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we conclude that ON equals to MB. ON equals to MB. But we have already found out that ON equals to R, it is the radius of the circle. And from this equation, R equals to ON equals to MB, we will derive that MB is also equal to R. MB equals also to R. Here, MB is also equal to R. So actually we found out that quadrilateral MOBN is a square because it has 4 equal sides. They are all equal to R. In the next step, I will present to you rule number 10 and we'll implement rule number 10 in our drawing. According to rule number 10, if we have the external point P, from the external point P we have tangent PA, tangent to the circle at point A, and we have the straight line that intersects with the circle at points B and C. Then, if this is the data that has been given to us, then the following equation is true, that AP square equals to PB times PC. Again, AP square equals to PB times PC. Okay, now we can implement rule number 10 in our drawing. Why? Because in our drawing if we focus on the external point C, from the external point C we have tangent CN to the circle, and we have the straight line that intersects with this circle at point C and D. Therefore we can implement here rule number 10. According to rule number 10, we get that Cn square equals to Ce times Cd. Again, Cn square equals to Ce times Cd. So I write it down. Cn square equals to Ce times Cd. Repeat again. On the external point C, according to rule number 10, we get that Cn square equals to Ce times Cd. So Cn square equals to Ce. Ce equals to A, therefore we substitute Ce by A times Cd. What is the value of Cd? Cd equals to A plus A plus A, that is 3A, so we substitute Cd by 3A. In conclusion, we found out that according to rule number 10, Cn square equals to A times 3A. That is to say, Cn square equals to A times 3A is 3A square. Here we take out all of this equation and we get that Cn equals to the square root of 3A square is the square root of A square is A, and the square root of 3 is the square root of 3. So in total we found out that the square root of 3A square is the square root of 3 times A. So we can write here that Cn or Nc equals to the square root of 3 times A. Likewise, we will focus on the external point A. From the external point A, we have, from the external point A, we have tangent AM to the circle, and we have the straight line that intersects with the circle at points D and at point E. Therefore, according to rule number 10, we get that AM square equals to AD times AE. Again, AM square equals to AD times AE. So I write it down. AM square equals to AD times AE. Repeat again. according to rule number 10, if you focus on the external point A, AM square equals to AD times AE. So AM square equals to AD equals to A, so substitute AD by A times AE. What is the value of AE? AE equals to A plus A plus A, that is 3A. So I substitute AE by 3A. So in conclusion, we found out that according to rule number 10, AM square equals to A times 3A, that is to say, AM square equals to 3A square. We take out of this equation and we get that AM equals to the square root of 3 times A. Okay, here AM equals to the square root of 3 times A. In the next step, I will copy the right triangle ABC in a new page and we'll analyze triangle ABC. So what is the length of side AB? It is very easy to see from the drawing that the length of side AB equals to square root of 3 times A plus R. Okay, again the length of side AB is square root of 3 times A plus R. And what is the length of side BC of the right triangle ABC? The length it is also equals to square root of 3 times A plus R. And what is the length of the hypotenuse AC? The length of AC is A plus A plus A plus A, that is 4A. So actually, this is the right triangle ABC that I copied from the original drawing. Side AB and side BC, they are both equal to square root of 3 times A plus R, therefore they are equal to each other. And we have the order in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. So if this angle is alpha, this angle must be also equal to alpha because of the fact that those two angles are equal to each other. In the right triangle ABC, this angle equals to 90 degrees, therefore the other two angles must be equal also to 90 degrees, because 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle, and especially in the right triangle ABC. So I found out that alpha plus alpha must be equal to 90 degrees. I write it down. Alpha plus alpha equals to 90 degrees. Alpha plus alpha is 2 alpha, that is equal to 90 degrees. We divide this equation by 2 and we get that alpha equals to 45 degrees. So I found out that angle alpha equals to 45 degrees. So actually, the right triangle ABC is also an isosceles triangle. We continue to focus on the right triangle ABC. the right triangle, triangle ABC. If we focus on this angle, we get that cosine 45 degrees equals to BC over AC. Cosine 45 degrees equals to BC over AC. So cosine 45 degrees equals to BC. BC equals to square root of 3 times A plus R over AC. AC equals to 4A, so we substitute AC by 4A. So in conclusion, cosine 45 degrees is equal to 1 over square root of 2. That is equal to square root of 3 times A plus R over 4A. Here we multiply this equation by 4A, and we get that 4A over square root of 2 equals to square root of 3 times A plus R. Here we substitute 4 by 2 times 2, and we get that 2 times 2 times A over square root of 2 equals to the square root of 3 times A plus R. Here we subtract from this equation minus, we will substitute one of the 2's by square root of 2 times square root of 2 here, and we'll get that so 2 is equal to square root of 2 times square root of 2 times 2A over square root of 2, and it is equal to square root of 3 times A plus R. We have square root of 2 in the numerator, square root of 2 in the denominator, so square root of 2 will get cancelled, and we left only with 2 times square root of 2 times A. It is equal to square root of 3 times A plus R. Here we subtract square root of 3 times A from this equation, and we get that 2 times square root of 2 times A minus square root of 3 times A equals to R. So here we take A as a common factor out of those two expressions. So A is a common factor. What is left from 2 times square root of 2 times A after we took from it A as a common factor? What is left is actually 2 times square root of 2. And what is left from minus square root of 3 times A after we took from it A as a common factor? What is left is actually minus square root of 3. That is equal to R. So in conclusion, we found out that the radius of the circle R is equal to A times 2 times square root of 2 minus square root of 3. Here, point O is the center of the circle, point D is the point of the circle itself, therefore D is the radius of the circle, that is equal to 1. In the next step, I will copy the right green triangle, triangle DOT in a new page, and we will analyze triangle DOT. So actually this is the right triangle DOT that they copied from the original drawing. From the drawings it's very easy to see that cosine theta equals to dt over do. Again, cosine theta equals to dt over do. So I write it down, cosine theta equals to dt over do. dt equals to a and do equals to r. So cosine theta equals to a over r. So cosine theta equals to a over r. And we already found out that r equals to a times 2 times square root of 2 minus square root of 3. So we substitute r here in this equation by a times 2 times square root of 2 minus square root of 3. Okay. So here we have a in the numerator and a in the denominator, so a will get cancelled. And we left only with cosine theta that is equal to 1 over 2 times square root of 2 minus square root of 3. Okay. Our mission is to find out the value of theta. So, in order to get the value of theta from this equation, we'll operate the opposite function of cosine, that is cosine minus 1 on the result. In this way, we'll get the value of theta itself. So, the opposite function of cosine is cosine minus 1. We'll operate it on the result, that is 1 over 2 times square root of 2 minus square root of 3. In this way, we get the value of theta itself. Okay. So, if we operate the opposite function of cosine, that is cosine minus 1 on 1 over 2 times square root of 2 minus square root of 3, we get that this expression equals to 24.203 degrees. So we found out that theta equals to 24.203 degrees. So here, the angle that we are looking for, this angle theta equals to 24.203 degrees. We finished the second question. In the next step, I will summarize the lecture. We start with the first question, of course. So, in the drawing, we have square ABCD. We know that line segment AP equals to 5 units, line segment BP equals to 3 units, line segment PC equals to 6 units, and our mission is to find out the area of this square ABCD. So first of all, we did the construction. We extended side DC of square ABCD by a straight line. And from point B, we go perpendicular on the extended DC. So this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point P and the extended DC as N. Then we did another construction from point B. We do perpendicular on PN. Again, from point B, we do perpendicular on PN. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and PN as M. Then we define side PM as B, we define side BM as A, and we implemented the Pythagoras theorem on the right green triangle, triangle PBM. On the right green triangle, triangle PBM, PB square equals to PM square plus BM square. I repeat again. On the right green triangle, triangle PBM, PB square equals to PM square plus BM square. The hypotenuse PB equals to 3 units according to what is given as the equation. So PB square is 3 squared, that is 9, and it is equal to PM square. PM is B, so PM square is B square plus BM square. BM is A, therefore BM square will be equal to A square. So in conclusion, we found out that according to equation number 1, 9 equals to B square plus A square. And we also know that all the angles inside the square are right angles. So in square ABCD we have 4 right angles inside square ABCD. And here we extended side DC by side line. So DC is one side of square ABCD, therefore it is absolutely a straight line. When we extended the straight line DC by a straight line, we add line segment DN. And when you extend a straight line by a straight line, the result must be a straight line, therefore DN is a straight line. And if we focus on the upper side of the straight line DN at point C, here the sum of the angles must be equal to 180 degrees. According to rule number 3, that the sum of the angles on one side of a straight line is equal to 180 degrees. That is to say, here 90 degrees plus the size of this angle, that is angle BCN, in total we must be equal to 180 degrees according to rule number 3. Again, 90 degrees plus the size of angle BCN must be equal to 180 degrees according to rule number 3. So here we subtracted 90 degrees from this equation and found out that the missing angle BCN equals to 180 degrees minus 90 degrees, it is equal to 90 degrees. So this angle equals to 90 degrees. Therefore, in quadrilateral BMCN, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So the fourth angle must be equal to 90 degrees because 270 degrees plus 90 degrees is equal to 360 degrees. That is the sum of the angles in any quadrilateral, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So this angle must be equal to 90 degrees. Therefore, we found out that inside quadrilateral BMCN we have 4 right angles. Then we focused on the lower side of line segment AEM. In the lower side of line segment AEM, this angle, we have this point B, we have this angle that is equal to 90 degrees, this angle that is also equal to 90 degrees, 90 degrees plus 90 degrees is 180 degrees. So here, angle ABM, this angle equals to 180 degrees. Angle ABM is equal to 180 degrees. So if angle ABM equals to 180 degrees, it means that line segment ABM is equal to if angle ABM is equal to 180 degrees, it means that angle ABM is a straight line. And if angle ABM is a straight line, it means that line segment ABM is a straight line. And if line segment ABM is a straight line, it means that AM is a straight line. Okay? I repeat again that any angle that is equal to 180 degrees, it must be a straight line. So here we found out that AM is a straight line. If AM is a straight line, it means that shape APM, this shape is a right triangle. So we will implement the Pythagoras theorem in the right triangle, triangle APM. The right green triangle, triangle APM. According to the Pythagoras theorem, AP square equals to PM square plus MA square. In the right triangle, triangle APM, AP square equals to PM square plus AM square. AP equals to 5 units, therefore P squared is pi squared, that is 25. PM equals to B, therefore PM squared is B squared. AM equals to X plus A, therefore AM squared is X plus A squared. So in conclusion, we found out that according to equation number 2, 25 equals to B squared plus A squared. Here we open the brackets on this side of equation number 2 and found out that according to equation number 2, 25 equals to B squared plus X plus A squared equals to X squared plus A squared plus 2AX. So here we have equation number 2 is B squared plus A squared, but according to equation number 1, we have already found out that B squared plus A squared equals to 9, therefore we can substitute B squared plus A squared in equation number 2 by 9. We did it and found out that 25 equals to 9 plus X squared plus 2AX. Here we subtracted 9 from this equation number 2, and found out that 25 minus 9 is 16. That is equal to X squared plus 2A squared. Here we subtracted X squared from this equation number 2, and found out that according to equation number 2, 16 minus X squared equals to 2AX. Here we divided this equation number 2 by 2x, and found out that according to equation number 2, A equals to 16 minus X squared over 2x. So we found out the value of A in terms of X. Then we return to quadrangle BMCN. Inside this quadrangle, we have already found out that we have 4 right angles. Therefore, quadrangle BMCN is a rectangle because it has 4 right angles. Quadrangle BMCN is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, BM equals to CN. BM equals to CN, but according to our definition, BM equals to A. And for this equation, A equals to BM equals to CN, we derive that CN is also equals to A. Here CN equals to A. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we get that BC equals to MN. But BC equals to X according to our definition. Therefore, for this equation, X equals to BC equals to MN, we derive that MN is also equals to X. Here MN equals to X, then we implemented the Pythagoras theorem on the right big green triangle, triangle PCN. According to the Pythagoras theorem, PC squared equals to PN squared plus CN squared. PC equals to 6, therefore PC squared is 6 squared, that is 36. And it is equal to PN squared. PN equals to B plus X, therefore PN squared is B plus X squared plus CN squared. CN is A, so therefore CN squared is A squared. So in conclusion, we found out that according to equation number 3, 36 equals to B plus X squared plus A squared. Here we open the brackets on this side of equation number 3, and we found out that according to equation number 3, 36 equals to B squared plus B plus X squared. B plus X squared is B squared plus X squared plus 2BX plus A squared. So again, here we have B squared plus A squared, therefore we can substitute B squared plus A squared by 9 according to equation number 1. We did it, we got that 36 equals to 9 plus A squared plus 2BX. We subtracted 9 from this equation and found out that 36 minus 9 is 27, that is equal to X squared plus 2BX. Here we subtracted X squared from this equation number 3, and found out that 27 minus X squared equals to 2bx. Here we divided this equation number 3 by 2x, and found out that b equals to 27 minus x squared over 2x. So we got the values of a and b in terms of x, and we have equation number 3. According to equation number 3, we already found out that according to equation number 1, a squared plus b squared equals to 9. And we already found out that a equals to 16 minus x squared over 2x, so if we square this expression, we get the value of a squared, of course. And we already found out that b equals to 27 minus x squared over 2x, so if we square this expression, we get the value of b squared. So a squared plus b squared equals to 9. Here we open the brackets of those two expressions, and we got that 16 minus x squared is equal to 16 squared, that is 256. Minus 2 times 16 is minus 32 times x squared. plus x squared is x to the power of 4. And because of the fact that those two expressions have the same denominator, we can add the numerator of this expression to the denominator of this expression. We did it and we got that 27 minus x squared equals to 27 squared, that is 729, plus x squared that is x to the power of 4, minus 2 times 27, that is minus 54 x squared. All divided by 2x squared. 2x squared is 4x squared, that is equal to 9. So here we have 956 plus 729 is 985, minus 32x squared minus 54x squared is minus 86x squared, and x to the power of 4 plus x to the power of 4 is 2 times x to the power of 4, all divided by 4x squared equals to 9. Okay, here we multiply this equation number 1 by 4x squared, and we got that 2 times x to the power of 4 minus 86x squared plus 985 equals to 4x squared times 9 is 36x squared. So here we subtracted 36x squared from this equation number 1, and found out that 2 times x to the power of 4 minus 86x squared minus 36x squared is minus 122x squared plus 985 equals to 0. So here we defined z as x squared. Z equals to x squared according to our definition. So if z equals to x squared, it means that z squared will be equal to x to the power of 4. Therefore, the expression 2 times x to the power of 4 will be equal to 2 times z squared minus 122x squared. We substituted x squared by z and we found out that minus 122x squared equals to minus 122z plus 985 equals to 0. So we have here a quadratic equation. 2z squared minus 122z plus 985 equals to 0 is a quadratic equation. And the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. This is the general formula for a quadratic equation. Here, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times ac over 2a. Here, the coefficient in our specific quadratic equation, the coefficient a equals to 2, the coefficient b equals to minus 122, and the coefficient c equals to 985, and the variable that we are looking for in our specific quadratic equation is z, that is to say x equals to z. So I copied again the coefficients of our specific quadratic equation. So we put the data inside the formula for x and found out the value or the values of z because x equals to z. So we put the data inside the equation and we got that z equals to minus b. B is equal to minus 122, therefore minus b is minus 122, that is plus 122, plus minus square root of b squared. B is minus 122, therefore b squared is minus 122 squared, that is 14,884, minus 4 times a. A is 2, so minus 4 times 2 is minus 8, times c. C is 985, therefore minus 8 times 985 is 7,880, all divided by 2a. A is 2, so 2 times a is 2 times 2, that is 4. So in conclusion, we found out that z equals to 122 plus minus 14,884 minus 7,880 is 7,004. So inside the root we left only with 7,004 divided by 4. So in conclusion, z equals to 122 plus minus the square root of 7,004 is 83.6899 divided by 4. So here we will have two solutions that are possible for z. The first solution for z is that z equals to 122 plus 83.6899 122.6899 divided by 4. 122 plus 83.6899 is 200.6899, and if we divide this number by 4, we get that Z equals to 51.4224. But what is Z? According to our definition, Z is equal to x squared, and found out that Z equals to 51.4224. So we took a root out of this equation in order to get the value of x. The square root of 51.4224 is 7.17 units. So here we found out that AB that is equal to x equals to 7.17 units. But it is impossible that x equals to 7.17 units. Why? Because if we focus on the right green triangle EPM, on this green right triangle, AP is the hypotenuse of this green triangle that is equal to 5 units. And the hypotenuse must be the biggest side in any right triangle, therefore the hypotenuse AP is the biggest side in this right triangle EPM. That is to say, it means that the hypotenuse AP is bigger than AM. So if AP is bigger than AM, let alone that AB will be bigger than AB that is part of AM. So we found out that the hypotenuse AP in the right triangle EPM that is equal to 5 units is bigger than AB that is equal to x. So we can find out that in the right triangle EPM, the hypotenuse AP that is equal to 5 units is bigger than AB that is equal to x. From this inequality, you will get that x is less than 5 units. That is to say, x must be less than 5 units. But we just right now found out that x equals to 7.17 units, that is bigger than 5 units. So we have a contradiction here. Yes, and due to the contradiction, we cancel this solution. That is to say, that cannot be equal to 51.4224 units. And we focus on the second solution for Z of the quadratic equation. According to the second solution, Z equals to 122 minus 83.6899 over 4. So 122 minus 83.6899 is 38.3101. And if we divide this number by 4, we'll get that Z equals to 9.5775. That is to say, Z that is equal to x squared according to our definition, it is equal to 9.5775 units. We took a root out of this equation in order to get the value of x itself, and the square root of 9.5775, it is equal to 3.09 units. So x equals to 3.09 units. That is less than the hypotenuse AP that is equal to 5 units. So we don't have any contradiction here. And what is the area of square ABCD? The area of square ABCD equals to x squared. That is to say, the area of square ABCD it is equal to x squared. That is equal to Z according to our definition. And we just right now found out that Z equals to 9.5775. That is to say, the area of square ABCD equals to 9.5775 square units. The area of this square ABCD equals to 9.5775 square units. We finished with the first question. Then I presented to you the second question. So in the drawing, we have a right triangle ABC. In the right triangle ABC, this angle ABC equals to 90 degrees. Inside the right triangle ABC, we have a circle inside the circle we have triangle DOE, and we are looking for the side of this angle, angle theta. It is given us the question that side and line segment AD equals to line segment EC, and line segment DE is twice as long as AD, and line segment DE is also twice as long as EC. That is to say, AD equals to CE equals to DE over 2. So first of all, we define the length of line segment DE as 2A. That is to say, DE equals to 2A according to our definition. And according to what is given as the question, we know that AD equals to CE equals to DE over 2. According to our definition, DE equals to 2A, so we substitute DE by 2A, and here 2A over 2 is A. So from this long equation, we can derive that AD equals to CE equals to A. AD equals to CE equals to A. That is to say, AD equals to A, and CE is also equals to A. Then I presented to you rule number 4, and we implemented rule number 4 in our drawing. According to rule number 4, the perpendicular from the center of a circle to a chord bisects the chord. The center of this circle is point O. We have the perpendicular OM, that according to this rule number 4, the perpendicular OM bisects the chord CD. That is to say, CM equals to MD. And we also know that CM is equal to half of CD, CM equals to CD over 2, and MD is also equal to CD over 2. We can implement rule number 4 in our drawing. From the center of the circle, that is to say from point O, we draw perpendicular on chord DE. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and DE as T. So here, according to rule number 4, dt equals to TE, dt is equal to d over 2, and TE is also equals to d over 2. Again, according to rule number 4, dt equals to TE, and they are both equal to d over 2. Okay, but here DE is 2A, so we substitute DE by 2A, and 2A over 2 is A. So from this long equation, we can derive that dt equals to TE equals to A. That is to say, dt is equal to A, and TE is also equal to A. Then we define the point of tendency of tangent AB with this circle as M. We define the point of tendency of tangent BC with this circle as N. Then we join points O and M together by a straight line. Point O is the center of the circle, point M is the point of the circle itself. This is exactly the definition of a radius. That is to say, OM is the radius of this circle, that is equal to R according to our definition. And we have the radius OM that is 1 to the point of tendency. Therefore, according to rule number 1, that the tangent to a circle is perpendicular to the radius drawn to its point of tendency. This angle will be equal to 90 degrees, and this angle will also equal to 90 degrees. Likewise, we join points O and N together by a straight line. Point O is the center of the circle, point N is the point of the circle itself, therefore ON is the radius of the circle that is equal to R. And we have the radius ON that is drawn to the point of tendency, therefore this angle equals to 90 degrees, and this angle equals to 90 degrees according to rule number 1. So in quadrilateral MOBN, we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees. Therefore in quadrilateral MOBN, we have 4 right angles, therefore quadrilateral MOBN is a rectangle. Okay, here quadrilateral MOBN is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, MO equals to BN. But MO equals to R according to what we have already found out. So from this equation, R equals to MO equals to Bn, we will derive that Bn is also equal to R. Here Bn is also equals to R. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we get that ON equals to MB. But we have already found out that ON equals to R. And from this equation, R equals to ON equals to MB, we will derive that MB is also equal to R. MB equals to R. So we found out that quadrilateral MOBN is not a rectangle but a square because all of its sides are equal to each other, they are equal to R. Then I presented to you rule number 10, we implemented rule number 10, and we implemented rule number 10 in our drawing. According to rule number 10, if we have the external point P, from the external point P, we have tangent PA that is tangent to this circle at point A. And we have the straight line here that intersects with this circle at points B and C. So if this is the data that has been given to us, then according to this rule number 10, AP square equals to PB times PC. Again, AP square equals to PB times PC. We can implement rule number 10 in our drawing. Why? Because in our drawing, if we focus on the external point C, from the external point C we have tangent CN, and we have the straight line that intersects with this circle at point C and D. Therefore, we can implement here rule number 10. According to rule number 10, Cn square equals to Ce times Cd. Again, Cn square equals to Ce times Cd. Okay. I'll repeat again. From the external point C, according to rule number 10, Cn square equals to Ce times Cd. So Cn square equals to CE. CE is A, so we substitute CE by A. Times CD. CD is A plus A plus A, that is 3A, so we substitute CD by 3A. So in conclusion, we found out that according to rule number 10, Cn square equals to A times 3A. A times 3A, A is 3A square, so we found out that Cn square equals to 3A square. We took out of this equation and found out that Cn equals to the square root of 3 times A. Here Cn equals to the square root of 3 times A. Likewise, we focus on the common external point A. From the common external point A, we have tangent AM, and we have this straight line that intersects with this circle, points D and E. Therefore, according to rule number 10, we get that AM square equals to AD times AE. Again, AM square equals to AD times AE. Repeat again, according to rule number 10, if we focus on the common on the external point A, AM square equals to AD times AE. That is to say, AM square equals to AD. AD is A, so we substitute AD by A times AE. AE is A plus A plus A, that is 3A, therefore we substitute AE by 3A. And in conclusion, we found out that according to rule number 10, in the external point A, AM square equals to A times 3A. A times 3A, A is 3A square, so AM square equals to 3A square. We took out of this equation and found out that AM equals to the square root of 3 times A. AM equals to the square root of 3 times A. Then I copy the right triangle ABC in a new page and we analyze triangle ABC. Side AB of triangle ABC equals to square root of 3 times A plus R. Side BC is also equal to the square root of 3 times A plus R. And the hypotenuse AC equals to A plus A plus A plus A, that is 4A. So this is the right triangle ABC that I copied from the original drawing. AB is equal to the square root of 3 times A plus R, and BC is also equal to the square root of 3 times A plus R. That is to say, those two sides are equal to each other. And we have the rule that in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front of the equal sides must be equal to each other. So if this angle is alpha, this angle must be also equal to alpha. This angle equals to 90 degrees, therefore the other two angles, those two angles must be also equal to 90 degrees, because 90 degrees plus 90 degrees is 180 degrees. It is the sum of the angles in a triangle, and especially in triangle ABC. So here we found out that alpha plus alpha must be equal to 90 degrees. Alpha plus alpha is 2 alpha, 2 alpha equals to 90 degrees. We divided this equation by 2 and found out that alpha equals to 45 degrees. So this angle was to 45 degrees, and this angle also equals to 45 degrees. Then we continue to focus on the right triangle ABC. In the right triangle ABC, cosine 45 degrees equals to BC over AC. Again, cosine 45 degrees equals to BC over AC. Cosine 45 degrees equals to BC over AC. BC equals to square root of 3 times A plus R. AC equals to 4A. And cosine 45 degrees equals to 1 over square root of 2. that is equal to square root of 3 times a over 4r. Here we multiply this equation by 4a and we found out that 4a over square root of 2 equals to square root of 3 times a plus r. Then we substitute 4 by 2 times 2 and found out that 2 times 2 times a over square root of 2 equals to square root of 3 times a plus r. Then we substituted one of the 2's by square root of 2 times square root of 2 and found out that according to this equation, square root of 2 times square root of 2 times 2a over square root of 2 equals to square root of 3 times a plus r. We have square root of 2 in the numerator and square root of 2 in the denominator, so square root of 2 will get cancelled. And we left only with 2 times square root of 2 times a equals to square root of 3 times a plus r. Here we subtracted square root of 3 times a from this equation and found out that 2 times square root of 2 minus times a, 2 times square root of 2 times a minus square root of 3 times a equals to r. Here we took a as a common factor, so here a is a common factor out of those two expressions. What is left from 2 times square root of 2 times a after we took commit a as a common factor? What is left? It is actually 2 times square root of 2. What is left from minus square root of 3 times a after we took commit a as a common factor? What is left? It's actually minus square root of 3. So in conclusion, we found out that r equals to a times 2 times square root of 2 minus square root of 3. Here we know that point O is the center of the circle, point D is the point of the circle itself, therefore OD is the radius of the circle that is equal to r. Then I copied the right triangle DOT in the new page and we analyze triangle DOT. This is the right triangle DOT that I copied from the original drawing. In this right triangle DOT, it is very easy to see that cosine theta equals to dt over do. Again, cosine theta equals to dt over do. Cosine theta equals to dt over do. dt equals to a, do equals to r. So cosine theta equals to a over r. So cosine theta equals to a over r, and r equals to a times 2 times square root of 2 minus square root of 3. Therefore we substitute r here by a times 2 times square root of 2 minus square root of 3. And so we have here a in the numerator and a in the denominator, so a will get cancelled and we left only with cosine theta that is equal to 1 over 2 times square root of 2 minus square root of 3. Our mission is to find out the value of theta itself. In order to find out the value of theta itself from this equation, we will operate the opposite function of cosine, that is cosine minus 1 on the result. In this way we will get the value of theta itself. So the opposite function of cosine is cosine minus 1. We operate it on 1 over 2 times square root of 2 minus square root of 3 and we got the value of theta itself. So if we operate the opposite function of cosine, that is cosine minus 1 on 1 over 2 times square root of 2 minus square root of 3, we will get that this expression equals to 24.203 degrees. That is to say, theta equals to 24.203 degrees. So the answer to the question is that the size of this angle theta, it is equal to 24.203 degrees. Okay, thank you very much.